everyone. So today, I will be explaining my addressing modes assessment in computer architecture. So for the first activity, it would be identification of addressing modes. This is the exercise 1. And for me to be able to answer this one, I would like to explain first what is addressing mode. So what is addressing mode? Addressing mode specify how an instruction identifies the data or operands. It operates on assembly language. This field indicates whether the operand is direct value, a memory address, or stored in a register. Addressing modes are important during instruction execution as they define the form of an operand and the way data is accessed, making sure the proper data handling at the machine level. So here are the answers for the exercise 1. The first given, mov AX BX, is a register addressing because the source operand BX is a register and the data transferred directly between a register, which is AX, without accessing memory. For the number 2, mov AX 1234H. The operand 1234H is a specific memory location, and the instruction directly accesses the value of a stored at address 1234H and move into AX. So this is direct addressing mode. Next is the mov ALSI. This is a register indirect addressing because the memory address is provided indirectly by the value in the SI register, and the value at the address pointed to by SI is moved into AL. For the next given mov BP plus DIAX, this one is base index addressing because the effective address is calculated as the sum of the base register BP and the index register DI. Data from AX is stored at this calculated memory location. Next is the mov CX, BX plus CI plus 08H. This one is a base index with displacement addressing because the effective address is calculated using a base register BX, an index register SI, and the displacement 08H. The value from this address is moved into CX. The next value or code is mov DIAX. This is a register indirect addressing because the address for the memory operation is provided by the DI register. Data from AX is stored at the memory location pointed to the DI. Next is we have mov AX BP minus 10H. This is a base with displacement addressing mode. The effective address is calculated as the value in BP minus the displacement 10H, and data from the memory address is moved into AX. Next is the mov AX 5678H. This is a base with displacement. Next is the mov AX BP minus 10H. This is a base with displacement addressing mode. The effective address is calculated as the value in BP minus the displacement 10H. Data from this memory address is moved into AX. Next, we have mov AX 5678H. This is an immediate addressing because the operand 5678 is directly specified in the instruction. This value is immediately moved into AX without involving memory. And finally, the last given is mov AX BX. This is another example of register indirect addressing because the effective address is indirectly provided by the BX register and the value from this memory address is moved into AX. Next exercise is to write code for specific addressing modes. Here is the exercise 2. Write code for specific addressing modes. Write 8086 assembly code snippets to demonstrate the addressing mode. This is the first given. So the answer for this would be mov AX 55AAH because the value 55AAH is directly loaded into AX register, and that's an immediate addressing. The next given is register addressing with the instruction copy the contents of BX into AX. So this simply moves the data stored in BX into AX. Looks like this. Since no memory access is involved, it's just a register-to-register transfer. Next, number 3 is a direct addressing. So the instruction is move the value stored at memory location 1, 2, 3 for each into AX. So 1, 2, 3 for each is the effective address, and the value at this memory location is read and stored in the AX register. So the answer would be move AX 1, 2, 3 for each. Number 4 is a register indirect addressing. Access the memory location pointed to by SI and store it in AX. So in this instruction, the answer would be move AX SI because SI holds the memory address. The value stored at the address is moved into AX. This is useful for working with dynamic memory locations. And number 5, retrieve a value from the memory address pointed by the sum of DI and displacement of 10H and store it in AL. The answer for this would be move AL DI plus 10H because DI is the index register. The displacement 10H is added to DI to compute effective address, and the value at that address is moved into AL register. Next is the base index addressing. In this instruction, we need to access memory using the sum of BX and SI and move the value into AX. The answer for this would be move AX BX plus SI because BX acts as the base register, SI is the index register. The effective address is calculated as the sum of BX and SI, and the value of this address is moved into the AX. Next exercise is address calculation. For the exercise 3, we need to calculate the given problem. So, given the base address 1000H, segment address 2000H, and a displacement of 10H, compute the physical address for the instruction move AX 1000H in direct addressing mode. And for number 2, compute the physical address for move AX BX plus SI plus 10H with BX is equal to 1, 2, 3 for each and SI is equal to 4, 3, 2, 1H. So to answer the number 1, physical address for move AX 1000H in direct addressing mode, the formula to calculate the physical address is physical address is equal to the product of segment address and 10H plus offset. The given value segment address would be 2000H. And the base address is 1000H. So, what we will do is, for the calculation, is get the product of 2000H plus times 10H, that would be equal to 20,000H. Then we will add the base address, which is 1000H. So the final answer for number 1 is 21,000H. Next, to get the answer for number 2, physical address for move AX BX plus SI plus 10H. The formula for calculating the physical address when using base index with displacement addressing is physical address getting the product is equal to getting the product of segment address and 10H and adding it to the sum of BX plus SI plus displacement. The given here would be BX would be 1, 2, 3 for H, SI is 4, 3, 2, 1H, and the displacement is 10H. So for step 1, let's get first the effective address. So BX plus SI plus displacement, we get 5565H. We will use this on the next step, which is getting the physical address. So physical address is equal to 2000H plus 10H, which is 20,000H. Then we will add the one that we get earlier, the 5565H. So the final answer for number 2 is 25,565H. The next exercise would be debug and analyze. Here is the exercise 4. We need to analyze the following code snippet and answer the questions below. So here is the code. So we need to answer number 1. Identify the addressing mode used in each instruction. So it's the same from what we've done earlier, in exercise 1. And for number 2, If the value at memory location 2000H is 1234H and at 2000H plus 10H is 5678H, what will be the final value of AX? So we need to get the value of AX for number 2. So for number 1, here are the answers, similar with the one we answers in exercise 1. Number 1 would be register indirect addressing. Number 2 is immediate addressing. Number 3 is index addressing. And number 4 is register indirect addressing. Now to answer the number 2, we need to solve for the AX. So the memory at 2000H is 1234H and the memory at 2000H plus 10H is 567H. That's in the given. So the first code was move AX SI. So this means we're moving the value from the memory location pointed by the SI register into the AX register. But at this point, we don't know what the value of SI holds. So AX is loaded with whatever is at SI. The next code is move SI 2000H. So here, we already have a value for SI, which is 2000H. So the SI register will be set the value of 2000H. The next code is add AX SI plus 10H. So here, SI is 2000H. We need to add 10H, which gives us the effective address 2010H. The value of memory location 2010H is 5678H, which is in the question earlier. So AX is updated with AX plus 5678H, which is here. So addressing mode is equal to base plus displacement addressing because we're adding the constant displacement 10H to the base register SI. So here we get the final value 68 ACH. Now for the final code, move DI AX. This moves the value of AX into the memory location pointed to the DI. At this point, the value of AX is stored in the memory location DI. So for us to answer the number 2, getting the value of AX, the final value is 68 ACH. The next exercise is practical problem. So for the practical problem, we need to write a small assembly program with the instructions below. First instruction, load the value 0 times ABCD into the memory location 3000H. So the code would be move AX 0ABCDH, which would load 0 times 0BCD to AX, and move 3000H AX, which will do start AX value at memory location 3000H. The next instruction is retrieve this value using direct addressing mode and it stores it in AX. So the code for this would be move AX 3000H, which would retrieve the value from memory location 3000H. Next instruction is copies the value from AX to BX using register addressing mode. So here it's very easy, you just need to put the code mode BX AX because it copies the value in AX to BX. And the last instruction is stores the value in BX at the memory location pointed to by using register indirect addressing mode, and we assume that DI is equal to 4000H. So here our code would be move DI 4000H. It will do is set DI to point to memory location 4000H. Next is move DI BX, which will store the value in BX into the memory location pointed to by DI.